it off. I really do want to let the panel do most of the talking here, because these are the folks that really kind of drove the building. But this session all about making the Iribe Center. I thought I'd tell a little story about kind of how we got going and why this was so important to me personally. So I got to University of Maryland in 1998, and I'll get up here. Mom says get up. Okay. Always do what mom says. So I got here in 1998, and the first day, right across the dorm was Michael Antonov, and we met. We hit it off. We started talking about video games and programming, and then shortly after, he actually relocated from our Denton Hall to another hall where he was roommates with Andrew Reese, and then we continued to talk about gaming and programming, and got to know Andrew, and together the three of us kicked off and decided to start a company and start programming in our dorm rooms and then eventually in an office. And for me, looking back, the relationships that I formed here at Maryland, especially with Michael and Andrew, but then with many people, many of my best friends are my college friends from University of Maryland. But that relationship with Mike and Andrew impacted my whole career. And Mike and I went on to work for 20 years together across, I think, 4 different or 5 different companies. I don't know. Everything we did together. Every company, whether I got there first or he got there first, we quickly followed each other and we were back together. Andrew as well. Andrew worked with us the entire time. And then when we lost Andrew and he passed away, we wanted to honor him, and so we put a scholarship together in his name, which led us back here, which then led to us getting inspired to do a building. And when we sat down to talk about what that building meant to us, what it looked like, and what we wanted to make sure it captured, it was really the relationship that we had formed, the three of us, and we wanted this to be symbolize that relationship. And so the Iribe Center has the Antonov Auditorium attached to it with the Andrew Reese Park on top. And that was very, very important for us to just show this connection of the three of us. And I think those are the kind of connections that hopefully this space can inspire other students to make and have that'll go on and affect their whole life. So that was one of the stories I wanted to share. The other one was, exactly why this building this way. And for the three of us, we ended up moving out to Silicon Valley and becoming a part of kind of the Valley's tech world. And you get really inspired seeing all the brain power together and all of the beautiful spaces that are created in Silicon Valley. And if you've gotten a chance to go out and visit some of the companies, whether it's Facebook or Google or Apple, I think we've probably all heard about the new Apple building, which is just kind of incredible. I haven't gotten a chance to visit it yet, but I don't know if it's as good as the Iribe Center, but it's up there. And in some ways, it's kind of similar. You see this big glass building, but that was really actually a lot of the inspiration was, can we bring that feeling of kind of advanced innovation and technology to University of Maryland? If you remember the previous building, A.V. Williams, was a little low on innovation and inspiration. It was a very dated building. It was a lot smaller. And I was really excited. Can we bring Silicon Valley to Maryland and create a space that would really inspire students and inspire faculty, that they would get to and they would, look around and be like, wow, it feels like, a Google building or a Meta building. And it would just be really inspiring to be a part of. And so that was the vision from the beginning, is can we build, Silicon Valley meets Maryland and really get people inspired. So that was a big part of it. And I heard a recent story, which I thought was kind of fun to share, which is we wanted it to have a lot of glass, a lot of windows, a lot of natural light coming in. Because again, the previous building was a little short, a little light on light. So we wanted to really open it up. And that's something that's popular in Silicon Valley, is really bringing a lot of natural light. Since you're spending a lot of time in the office programming, you want to be able to look out every once in a while and be like, oh yeah, there is, life outside of the office. and you want to look out to nature and things like that, and just kind of feel good, take a breath, and then get back to work. What I think we didn't consider, and that has now come about, is this is a space for advanced computing, computer science, and robotics and engineering. And as it turns out, getting robots to work in an all-glass building is actually quite hard. And getting computer vision to work with windows all around, where everywhere it looks, there's reflective, partially transparent windows, is actually a big challenge. And recently somebody came up, a faculty member, and said, yeah, you wouldn't believe how hard it is to get robots to work in the new building that's supposed to be the robotics center. And I said, well, we did that on purpose, of course. We wanted to challenge you guys. And if robots are going to work in the real world, they got to work with a lot of windows. So, of course, we knew that from the beginning. Yeah, but no, it really is inspiring. And to kind of come into this space and see some of those robotic labs on the first floor and see the, drones flying around or the robot arms doing their thing. For me, I mean, I just would be so inspired if I was here, and I'm really proud of what the team has created and what the faculty has done with it. So it's very cool to be back. Every time I come in, I usually try to sneak in on the holidays, and then just go through the whole building and look at all the different spaces and floors, go up to the Reese Park and take a deep breath and remember Andrew. And I'm really proud at how this building has turned out. And I just appreciate everybody that worked on it. So it's good to be back. And I'll be here if anybody has any questions also, but I want to turn it over and let the team do the talking. So thank you, guys.
Thank you, Brendan. That was probably as beautiful of a keynote opening to tee us all up than ever. But thank you again for everyone to join us this morning with the keynote session here. My name is Sally Lee. I'm an architect at HDR. We're the architecture firm that worked with Brendan, as well as University of Maryland, to bring this new signature architecture to the campus. I'm joined today this morning with my colleague, Simon Trumbull. He's design principal at HDR, who was a lead architect and design on this project, helped spearhead a lot of the concepts, again, marrying what Brendan kind of teed up as the poetics meeting the pragmatics. And then Jeff Hollingsworth representing the perspectives of the university with us today. He's Vice President of Information Technology and Chief Information Officer of University of Maryland. So as you can imagine, designing a building for computer science, pretty critical to have the CIO on board and helping us bring forth the vision. So to kick off, I'm going to actually hand it over to Simon first. With the question to tee us up here today, which is not many people in the audience are architects. So I think from your perspective, as Brendan kind of mentioned, the origin story for how this building started, can you kind of just walk through how a building like this begins and the journey of all the considerations we had to think of?
Well, this question can go in a lot of different directions, but I think when we start talking about a building that's at the front of a university, one of the big questions is to make a gateway for that university. The other question that came about is we have a bunch of program spaces and we have a site, and the site has certain restrictions along with that. So how do we create a knowledge center, which is a fundamental question for any university? How do we simply create a knowledge center? And then the question that Iribe asked us was, how do we bring energy? How do we unlock that emotion so that this building becomes alive? It's very kinetic. So the relationship to nature, the aspect of gateway, and the simple program, how do we bring those together? That was the question. That's fundamental to creating an architecture like this. Opening the building up, essentially creating a vortex on campus. If you notice the shape, it's simply two objects. A tower that starts with the grid of the campus, that turns and points itself to the future and to the past, and an object that's anchored to the ground. We're in it, the auditorium itself. And then that vortex swirls around and invites you in. And we entered that empty space. We entered the void, and it's that void that is the energy space for all of these, for what I'll call pragmatic spaces. Hopefully that gets
Yeah.
the essence of it.
I think to add on to that a little bit is that I was just upstairs looking at the box of the visioning for what people thought 2023 was going to be, and they were saying that we would still be in A.V. Williams was on the prediction for 2023. So pretty incredible. In 10 years, the Iribe Center has landed on College Park. But I think one of the differences that we were knowing the directive that we were given, that they wanted this to be a synthesis of a lot of ideas, a lot of thinking, new sort of synergies. A.V. Williams was pretty difficult to locate where the front door was. And so the Iribe Center, the idea behind it was not only do we have a really clear front door, we have 4 of them. And we've introduced ways to enter the building from 4 different directions. And that is really to create that destination piece that Simon talked about, to welcome ideas and also create those really energetic spaces at the facade or the exterior. I was told not to say architecty jargon. The exterior, to welcome people into the building to see science on display. That is essentially the directive. And so from Jeff, your perspective, again, as Chief Information Officer, I think you were such a critical member of the team from the University of Maryland side to ensure that this building performed. So can you talk us through some of the goals that you intended for the job, and also how they were realized, and maybe a couple of other things that spun out from it?
Sure. Just to set the record straight, although now I'm Chief Information Officer, at the time I was a CS faculty member designing what I thought was going to be the office I would spend all my time in. And I ended up spending a lot of my time somewhere else in my new job. But as the building was evolving, I took this job and kept my hand also in this project. But at the time, the real vision was to bring people together, bring together disciplines across the campus so that, the interesting problems in science are at the nexus of different disciplines. And so that, how do we get people to come together, both physically, but then also together with ideas and building spaces that can do that. You talked a little bit about putting it on display. And so one of the things we did was the first floor space, where there's so much where you can actually see the robots and see them flying around, struggling to see through the sunlight that's pouring in. But that was on display, was a real part of the vision and expectation. The other thing to build on Simon's comments about is the architects started to envision the space. The architects had the site to work with, the client's needs from the university, and also the goals of the donor. And so all that came to a head. I remember when with some HDR folks, we flew out to California and went to Brendan's office and brought 3 models of possible shapes of the building. This was one of the designs. Another one looks sort of like a starfish. I can't even remember what the other one was.
I have them at the office.
We had them all.
We have them, we didn't bring it. And going into that, Brian and the university folks, we strongly favored this design. It's like, oh my God, what's the donor going to say? And Brian said, don't worry, I'm confident Brendan will like this design. And so we pitched it. Brendan loved the design, I think. And then Brendan stepped out to take a phone call. We were sitting in his office and we were relaxing, having had this pitch. All of a sudden, Kristen came in and said, well, I'm glad this went well, but Brendan sort of needs his office back now, and we got shooed out of his office. But it was a great collaborative process. That's what I think is really important.
You got the answer you needed. So
we got the answer we needed. Hopefully you like the answer.
Get out. Yeah, he liked the one we liked. Well, you guys did just a phenomenal job. It was very impressive, and it was very exciting. I mean, to bring these models out, for one thing, the models were well done, and I just loved them. I wanted to keep them all, but especially the one that we all agreed was the right direction. And you did let me keep it, which was so cool. And I still have this 3D printed model, and I'm just really proud of it. One of the other points I wanted to highlight that needed to be considered, that was, again, a pretty big challenge, was we wanted this to be a high-tech space and represent kind of Silicon Valley and computing in Maryland, but it also had to match University of Maryland. It couldn't look like a building from space or plopped out in the wrong space. So it really needed to kind of blend in. And I thought the team did a great job at bringing that kind of brick and infusing the brick around this kind of future space and high-tech space. And so I really think it's awesome how it's kind of like this technology from the future meets University of Maryland and the vibe that it has here. So.
Actually, fun little fact behind that. So we knew that brick wanted to be integrated because of the heavy brick aesthetic of the university, but we wanted to do it differently. So we used a very traditional building method, but in a very unconventional way. So hence, if you're familiar with the outside of this brick wall and from the lobby side, there's these parametrically sort of rotated bricks that create a dimensional aesthetic to it. And so as a fun little fact, I don't even know if, Brendan, you know this, but we have a parametric design tool called Grasshopper where you can script it to essentially help design what those rotations can look like. You can set it to be a word, you can set it to be a pattern, but at one point we set it to be your face, and just to test the script. And just
Definitely didn't know that.
But we tested it as a parametric tool to see like how responsive can we get the rotations to work, and they're pretty responsive. So there was one that's like literally a relief of your face. And we're like, he probably won't go for that one, but let's just show the other ones. Yes.
So if you look at the building sideways,
upside down, yeah. Yeah, exactly. So actually, that's a great kind of segue that we talked about technology, not just from the design standpoint, but also from the building standpoint. Simon, can you talk a little bit about the use of technology to carry forth the vision and a couple of the challenges that came from the design from the site perspective? I think there's a couple of site stories that kind of the people are not familiar with. So the technology of construction and design to pull this building off.
Okay. That's got a lot of things to it. But I think probably one of the most powerful ones is, this is actually a fairly large site. I don't know if people remember the old building here, but this was a large parking lot here. And if you remember that large parking lot, it actually flooded quite a bit. So when we were given the site and they said, oh, we have this great site, and we looked at it and said, oh my gosh, there's a lot of space here. We started to design some things and we got the flood map back. If you guys realize that glass wall that we have outside is the line of the flood zone. So the building actually cantilevers. You're not allowed to build in the flood zone. This building cantilevers over it. So that large column space that we have is not just for fun, but it's how we can get this entire program pulled together onto this site. This auditorium is in a sense backwards. We're a large space above a small space that has an air conditioning system on top of it. Wouldn't normally want to flip that around, but this large space on the ground. Part of that, again, has to do with the water levels and where we're at. So, you know, there's the willful side of it, there's the nature side of it that comes together, and we kind of design around all of these parts and pieces in order to make that happen. I think probably that technology-wise, the basement, the system, to do this shape, to do the brick the way that it's done, I'll call it unusual, to do these panels at this size, this whole system here, again, Sally was talking about, this is an algorithm script to be able to develop this, three-dimensional shapes to come in here. It's also carved for acoustic properties. Same thing with the ceiling. All of these come together. The technology of the classrooms, the glass walls, you know, they have to meet certain acoustic levels, but also be inexpensive enough to pull off. Those are a double glazing system. Again, because we want the energy of what's going on in the classroom to be seen outside, to be shared, but also to be controlled. So, you know, there are aspects of the building that happen on multiple levels, and not just from the perspective of the user, but from the perspective of the need of nature, in a sense. Yeah.
And then the park on top. And I remember when we pushed for the park on top, originally there was this kind of concept that came back, and it was like a small little park that you'd go up and kind of look out over. And I said, no, I mean a park like we're going to turn most of the roof into a park. And I remember the team, it came in, it was a little bit a later concept. So, it, you know, those 11th hour ideas, once you're done and everything works, and then somebody kind of changes it all. But the team reacted so well to really seeing that vision through. And I think that was another challenge that you had to wrestle with, was now suddenly a big amount of the roof where normally you put a lot of equipment and HVAC and different things on, suddenly was going to get turned into a livable, walkable space that people could share, that also was going to have plants and trees and irrigation and a waterfall. And there were, we kept adding to it. And it was really exciting. And glass, because you had to walk around and see off. It couldn't have walls. So that was a big challenge that I thought you guys just nailed.
That's a good point. I think kind of segued to Jeff now. So as Brendan mentioned, the Reese rooftop was a venue space. I think that got introduced later in the design story. But with Antonov Auditorium that we're sitting in today, the cantilever space on the underside, the rooftop on the top of level 1, the lobby, all of these are sort of venue spaces that invite not just the university, but community and industry to come to the Iribe Center as a destination. So Jeff, from your perspective, how has the technology been able to support the program, not just for the university and the curriculum, but for industry at large?
I think the program has worked incredibly well. There are a lot of gathering spaces, formal like this space, but some of the ones I'm most proud of are the informal ones that are on the different levels. Each of the spaces at the end of every floor are informal spaces on almost every floor. And those were designed as gathering places, not just for the building occupants, but for the students across the campus, for the community. That space has been used remarkably well. Every time I wander through the building, there's students there. And that was very intentional, because when we went out and looked at other computer science buildings, we took a road trip to a number of different universities. We often went into these CS buildings that were empty and sterile, and there were not people. And in some cases, there were plants that were put there to try to make it look better, but there were no people. And I said, and at one point we said, like, let's not fill this with plants, let's fill it with people. And so, at one point I said, like, the undergraduates, they're going to be our potted plants. We want them around to make the space look better, but the students love it. I talk to students. My oldest child is a junior here in CS now, and all the students love the spaces, the informal spaces, and those connections that you made with Andrew and with Michael as a student, I think students are making here in our building now, and that's really special.
Absolutely, and I think for the venue perspective, Simon, the design team definitely talked about this a lot, was how do we create a space that students can not only learn here, but they can study here, they can eat here, they can play here. And so it's exactly as Jeff mentioned, the infrastructure to allow for all those program spaces to come together, and also to, again, create those friendships that last a lifetime, which goes beyond, again, just learning.
So there's one I will share. The two deans in the room, cover your ears. Apparently, frequently, Friday and Saturday night movie nights are being organized in this room without probably the knowledge of most people here. But I've been told students gather and they play movies and watch sports and do other things, as well as some video game tournaments that go on in this room that are not officially sanctioned, I think.
I want to go to the video game tournament.
I'd like to add on a little bit here. When we were discussing A.V. Williams earlier. I mean, the essential problem with A.V. Williams is that it's classrooms in a hallway. So if you want to, you go to the classroom, you learn, but you have to leave. Fundamentally, you have to leave. The dormitory became the place where you did food, you played video games, you studied, and you created. So how do you take those simple aspects, bring it back into the building? So you don't leave. You play here, you study here, you relax here, you make, you hack, and this becomes energized in that way. That's the question. How do you unlock that emotion? And you have to create the space for that to happen. Sometimes that space is simply void. That's very gently programmed. Sometimes that space is the garden area. Sometimes that space has the connectivity, the power, the screens to make it happen. And if you look around, if you get a chance to tour the building, you'll see that everywhere.
Yeah, I wanted, just hearing you guys talk, point out, traveling around, like walking through A.V. Williams, actually led to some of the ideas, because we essentially wanted to do like the opposite of A.V. Williams. And there were, like you said, there were some of these classrooms in the center of the building that literally had no windows. They were a huge room, and with hallways around that then had offices outside of the that hallway on the other side that may have had a small window, but by the time you got through that office, through the hallway to the room in the center, all the natural light was gone, and you were just in a little box completely closed. And so that led to this idea: can we let that natural light come all the way through the building? So even in the center of the building, when you're in that classroom, you're able to look around and see outside of the whole building, and that natural light will flow all the way through, and you can see other people. You can meet people there, but you can also see all these students collaborating, because you can essentially see through the whole thing. And that led to, again, a lot of glass and a lot of transparency in the space that I think is really powerful. It's really cool. And it kind of reminds me of what happens in Silicon Valley. Like, I think there's, at least if you've ever spent time at Facebook, Mark's office in Facebook, his main office where he has meetings, is called the Aquarium, because it's an all glass room in the center of the space that you can completely see in. And he said, I don't want to be in a private enclosed office where, I have private meetings and people wonder what's going on. I want people to be able to flow through the space and at any time look over and see who I'm meeting with, what I'm doing. And they can walk over, they can even kind of stare inside. I think they've had to shoo people away from it a few times. I remember having a meeting in there, and you look out and there's like a tour group going by and everybody's just staring at you. So it can get a little odd sometimes, but I think it really worked out well here. And it's very cool to see how much open space there is.
I think the good kind of point there is the high bay labs on the ground floor that we put signs on display. I think that was one of the objectives as well, that they wanted this sort of democratization of creativity space, essentially. So you have a lot of those major firms that were all started in a garage. You have like the Apples and the Googles and the Microsofts all started in a garage somewhere, but not everybody has that kind of access to that kind of space. And so those doors in the high bay labs can open up, and you can drive cars in, you can drive robots in. So that garage space is something that we brought to the campus to allow students to be able to innovate and create and have that access to the kind of spaces that allow great ideas to happen. And very similarly, as Brendan and Jeff both mentioned, the glass and the transparency and the socialization aspect of it, and even the opening story, Brendan, you told of, your three friends that came together, and this is sort of like the poetry behind this building, very much is the poetry behind all connections and sort of the way that we wanted to structure the architecture to, again, create those sort of friendships and dynamics. And so to close, I think we're coming up on at least the scripted portion to open to Q&A, but I would say, Jeff, from your perspective, having been at this building now a couple of years now, how has the building been able to support sort of what we intended the goals to be? And any surprising or unexpected things spin out from it as well?
Sure. There's one story I'm really fond of. It actually happened last month, and it was sort of at the nexus of what we had designed for and maybe what we had hoped would happen. And at the University of Maryland, we have an arts festival, and it's next now, and it runs for several weeks, and it's all across campus. And that art festival has been all over campus through the years. And there are different programs. A lot of them are over in the Performing Arts Center where you'd expect it. But this year, the Immersive Design program had an arts display in the high bay and lobby space in this building. And what was amazing is those pieces were at the nexus of some were technology, and they were clearly going to be techie things, and some were just art, some were just digital art, not even interactive digital art, but beautiful art. And that we would view coming to this building and seeing not just technology as the next technology thing, but as technology as art was always something I had hoped for the space. I think, Brendan, you had some similar hopes. And to see that manifest and see students who were here who showing off their student works as part of an arts festival was something really special to me.
At this moment, kind of open up to questions unless there's, yes.
I have a front row question, and it's mainly directed to Jeff. So what role do you think Wallace Lowe, sorry. So What role do you think Wallace Lowe, the prior president, played in the overall design and creation of this building?
Well,
I don't know if that came across.
right. So the prior, yeah, so it's, I'll repeat it. So Wallace Lowe was our prior president, and what role did Wallace play in creating and making the center happen? And I'll offer a couple things. First of all, Wallace is the president of this university who most cared about the arts I've ever seen. And so he was highly supportive of the focus on arts. And the other thing I will say, and again, I realize I'm now a senior administrator in this campus, the best thing senior administrators can do is make a few comments and get out of the way and let the experts do their job. And I think that was also a major contribution.
Yeah, I think he really supported this program through funding. This building, as much as I'd like to say, yeah, funded the whole building, I only actually funded a small part that got it kicked off. Mike and I put in a small contribution relative to the rest of the funding that had to come from the state. And the president really, with the faculty, rallied around convincing the state to put up all of the funding, even additional funding, to make this as big of a space as it could be, as we could imagine it to be. And so I really appreciate the work he did to get this project funded the way he did.
Well, I get it. So it's wonderful how this building kicked off a renaissance in the sort of architecture in this part of campus. And so many new buildings which have come up since, and so many more which are coming up. So, Brendan, what's your perspective on the new, other buildings which are sort of companies your vision?
I think it's really inspiring every time I come to campus. There's not just new buildings on campus. It seems like there's a lot of new buildings around campus. This space is being built up every few months. It feels like there's more construction, new housing, new spaces being made. And it's very cool to see it grow the way it is. In particular, on campus, there are a number of new buildings. I assume many of those come from different donors that again seed it, and then it gets state funding and kind of takes a life of its own and becomes this great new space. And many of them have a bit of a tech forward, innovation forward look. They're kind of starting to stretch beyond just the brick style to a brick meets the future. And it's very inspiring. And so I think rebuilding may be one of the most kind of tech forward, and then you see these other buildings all starting to feel like they're pulling towards the future, and they're very inspiring. So I love seeing each new building, and makes me want to do more. Not yet, but I have to be careful when I say that.
Yeah, this building is already full.
Hi, thank you. I'm Dinesh Manoj. I should tell you, I came here in 2018. This is definitely, I've been to a lot of computer science buildings, and if you look at worldwide, most top universities, MIT, Stanford, UT Austin, CMU, Cambridge, they have the Gates building. But maybe I'm biased. I've not seen a building like this. So for a lot of us, this building and the place, when I missed the building the most, when the pandemic hit. We could not come here for a year. And one of the things I should always tell Brendan, I work in robotics with engineering and all that stuff. It's a great building. It's not robotic friendly yet. And as you heard Brendan talking last night, when enter of AI, he described what Waymo ride. So Brendan, we are working on making robot friendly. We're going to solve that goal together. Thank you.
Now you know who was talking to me about the windows. I mentioned this story earlier about the windows being a challenge for robotics. And of course, that was by design. We just wanted to make sure that we had the most advanced robotics group. But it's very cool to see the work you guys are doing. And it's great to hear. I am really proud. When I see this building, I can just imagine, being here as a faculty member. It's so inspiring to be in a space that you love, that you're proud of. And I hope that's the feeling that everybody has.
was, I've been in the valley as well. That's where I work. My question is, in the valley, we tend to also weigh benefit and risk. And so for you as an entrepreneur, getting into this project, receiving money, but you're not sure if you're going to meet all the expenses for the building, you have to work with the state. How can you talk us through how you fostered that relationship? Because we know government can be bureaucratic. You have to work through many red steps. And so I don't think it was a smooth ride. What are some of the challenges that you went through, or you as a team, with the university as well, trying to lobby for this building and showing really the importance of why this building, why now, and why there?
Sure. Where the initial idea, there's kind of a fun story we've told many times around the kind of very moment that the building commitment happened, which was I went to get a tour of AV Williams when we came back, and with Michael, he and I were on a tour. They walked us through, and as we were leaving, I needed to go to the bathroom, and I said, "Oh, let me just hop in the bathroom at the bottom of AV Williams." And Samir, the dean at the time, said, "Oh, no, don't, not that bathroom." And I was like, "Nah, I need to go. It's just the bathroom. It's totally fine." "Oh no, it's a little rough right now. They're doing some work on it." And I said, "Don't worry. I've been to a lot of bathrooms. It's totally fine. I'll be quick." And I walked in, and it was quite rough. It was rougher than expected. And I came out and I said, "Wow, yeah, you probably shouldn't have let me go in there." And then we jumped on a golf cart, and we were going around, and I just thought, how can the University of Maryland, which has the computer science department is, I believe, the biggest department at the time, still is, here, and it's putting out so many great students and has so many great faculty, have a space that feels so dated and hasn't been updated. And it just feels like something that we should help. And so I was asking those questions on the golf cart as we were getting the rest of the tour, and they said, well, it really takes public donors, alumni need to donate because this is a public university and we really rely on alumni, and we just haven't had an alum donate to the computer science department yet for a new building. And I thought, well, that's our calling. This is the moment. And so I said, well, we should do that. And the golf cart stopped. And that's why I got to be careful when I say we're excited to do more. But the golf cart stopped and they got off and said, what do you mean, you should do that? And I said, we and I looked at Mike and I thought, yeah, we should do a new building. That would be great. And the good news at the time was I didn't know at all what that meant. Actually, I just thought we could help get it started. I didn't know. And Mike looked at me and said, in his Russian accent, do you have any idea how much a building is? Luckily, I didn't. And I just thought, no, it can't be too bad. And look, this whole Oculus acquisition thing came as a pretty big surprise to us. And it's a life-changing moment that would be so much fun to share. And, again, it kind of happened all so quickly. And it's like, what are we even going to do with this? You figure it out after a while. But at the time, I thought, what better way than to help? And so I think part of what led to it was really just the inspiration of wanting to give back, wanting to make an impact here at Maryland, which had made such a big impact on my life. A little bit of not knowing what we were getting ourselves into also played into it. But for me, the biggest realization and the thought that was going through my head at that very moment was, wouldn't it be more fun to be a part of giving back while we're alive, while we're young, while we're still working even, than just when we get old or even are gone and then somebody does it for us? Wouldn't it be more fun to do it ourselves and then be able to participate in it and be able to come back and talk to students and talk to faculty and be here today and imagine we're going to do this for decades. And that's going to be way more fun than just our kids or kids do it for us. So really it was, going and wanting to be a part of it. It felt like the right calling. It was very needed. It felt like something that we could do, Mike and I, And I love doing everything with Mike, and we were there to honor Andrew, and it just all kind of felt like the stars aligned and it was the right thing to do. And we didn't fully know what we were getting into. So it all added up, and it was really, really great. And I'm so glad, like I look back and I'm just so glad that we did this.
So to the question, oh, yes. What bureaucratic obstacle did we hit? And I will say the number one bureaucratic obstacle was Brendan came from Silicon Valley and wanted to move at Silicon Valley time. This is building construction time. This is state of Maryland time. And getting those three closer to Brendan's vision of the timeline, we could do this. You gave some goal.
We did a lot of Oculus VR demos to state officials, which actually turned out to be a ton of fun. When Wallace and the team here at the time would say, you know, okay, in order to rally all the rest of the funding, because again, we just seeded it with a small amount. It really came from the state and from other donors. To get everybody around that, we need you to go out and help champion this. And I thought, sure, I'll talk to some people. And they started lining up the governor and lieutenant governor and mayors and just everybody that we needed to go talk to. And it was great at the time because we were also launching Oculus and VR. And everybody was excited to try Oculus for the very first time. So we have these great photos and stories of going to meet the governor, putting the governor in VR for the first time and watching them experience it, having them take it off, and then talking to them about the building that we wanted to create, the vision that we had to inspire more students to make things like what you just tried. And luckily, VR is kind of like conversion on contact, as we say. It's so powerful that I think as soon as they took it off and they were kind of amazed at what they just experienced, and we said, wouldn't it be neat if there was more of this coming from Maryland? They're like, yeah, I'm still processing it all. Great, sign here. And it definitely all came together, I think, very quickly. I think quicker than most government officials were expecting or anticipating. We got them to accelerate the budget. Again, it still felt kind of slow Silicon Valley time, but really it did come together very quickly. And I really appreciate Maryland's effort to move so fast to get the project going. They advanced budget, they pulled budget from the future. They did all kinds of things to get this kicked off quickly.
I think from the architecture perspective too, I would say that it actually changed a bit of how we practice as well. Because I think that the Iribe Center was, if not the first, but definitely one of the first, but if not the first, project that we built in VR. Because we're like, we can't do a computer science for the guy for VR and not do it in VR. So that was part of it as well, that we actually did a VR model and was able to walk around the Iribe Center virtually. So I think it changed a little bit of our processes as well as a design company. So in that sense, the ripple was sort of beyond just the project team, but also to the design team and our firm at large. So that was pretty an interesting spin out too.
A fun little side story, which, we kind of kept off the record, was for a while after seeing this VR experience, I was so excited to put this VR experience out, actually being able to be in the building so everybody could see it. And we had this vision of we're going to open source and put out the whole model so everybody could see it. But then we started to realize what people are going to probably want to do. Students are going to want to run around and play shooting games in this building, because of course that's what you do in a first person experience when you can run around a building. So we thought, let's not take that risk, quite yet. But it really was very exciting to see the space. And I still have aspirations and dreams about showcasing it, in the future, doing some more VR experiences of the building for people to see. It's very, very cool.
I had a question following up on this, on the role of technology and computer science and architecture. I think it's so cool that, when we hear you talk about the design process, how much computer science is actually used to design a building like this in terms of procedural design, PR in the design process. So I'm wondering what this will look like in the future, especially with AI and the possibilities that we see in many creative fields for total disruption and absolutely new ways to create things. So, looking forward as architects, how do you, what is your sense about that? What are the opportunities and what you see, the changes that will come because of AI and new technology in your work?
I find it fascinating. You only have to go back about 10 years, and we started with what's called BIM today, which is three-dimensional modeling and scheduling, essentially. Go back another 10 years, and you're starting AutoCAD, which is single line, kind of two-dimensional, forced into three-dimensional. Go back another 10 years, and you're hand drafting. So where are we today? We're at the edge of BIM, but the introduction of algorithmic and the beginning of AI into the architectural world, into the construction world as well, because we're adding time to phasing of buildings, right? So the ability to create a schedule through time graphically is available, and most contractors on a large scale are already doing that. Architecture is always slow. We're worried. We practice away. We have a lot of risk aversion. Everything we do is for the first time. So we don't work on scale per se. This building will not be replicated. So every joint, every corner, every edge is for the first time. So there's some trepidation a lot of times because of that. But there's also the promise of being able to go through that much easier. When we put this into the VR world, we're able to look into corners of the building that we really hadn't thought through properly. There's little edges around the staircase. There's corners around. Actually, this space coming up at the end here, we spent a lot of time right up in this corner. There's many things coming together right here between a skylight, the stairwell, the curve, the end of this wall, the three-dimensional nature of this wall, as an example. We had to study that quite a bit. So right now, BIM is beginning to accept plugins, and all of those plugins essentially becoming a framework. All of those plugins are beginning to allow us to test, to measure the building at multiple levels: lighting, acoustics, structurally, visually, materially, perspective-wise, walkthrough-wise. All this is coming together. That next step is bringing program into it and allowing the computer, and this is beginning to happen, allowing the computer to test multiple optimizations, I'll call it, purely off of numbers and off of information.
And I think a segue off of that. So our company, we also do a lot of, we actually have a group of computational designers that use a lot of those tools. And so parametric tools, machine learning even, teaching computers like what to recognize as like a module, or like what the rhythm is, replicating it, and these sorts of things. So it is quite interesting at the cusp of it. How do we sort of manage that, but also use it very much like, again, BIM or CAD or anything like that was as a tool, not necessarily a driver, but as a tool to either validate or support certain design processes. So I think that it is an interesting bit. And I think that, to Simon's point, because of the risk doing work that impacts public health and safety, we're very risk adverse because you can't really experiment with these sorts of things that, people's lives are at stake. So we are very slow to adopt some of those things, more out of safety reasons than innovation reasons, but safety reasons. So I think that from that perspective, we are sort of a bit. Yeah, but I think, again, it's thinking about it properly versus because back in the day when we were hand drafting, it's not like people were walking around selling their T-squares. Like, this is architecture, But we understand the relationship with AI as a tool for architecture.
So for instance, DALL-E is actually entering the architectural world at the school level and beginning to show up a little bit on in the professional world, where you can do a design or 2 or 3 and then kind of ask DALL-E to make some versions of it, for instance. And this is, again, just graphically, right? This isn't without much more. And there's some interesting things that can come out of that. Today we're still involved in terms of the human aspect of it, but I could see sometime in the future where some of that decision making or some of that, I'll call it foundational, simple structure will be done. And then beyond that, probably smarter than us and will do it better, you know.
I am really excited about the future of AI now. And I do think the way that you framed it, I really like when you look at these kind of chapters of innovation where you had the hand line drawn, the T-square, and then it transitioned into the flat 2D AutoCAD world, and then it kind of transitioned into a real three-dimensional BIM model world. I think, you know, we continue to improve the visualization side. I think that will continue to improve. We'll go more and more into a virtual visualization world where we can start to visualize it easier and more realistic in 3 dimensions with 3-dimensional displays. That's going to be a long path. Again, another 10, 20 years. But AI in particular, I think we are at the cusp of finally getting to a new interface where the last few decades have really been dominated by the graphical user interface, which is AutoCAD and BIM. Even VR is a graphical user interface. I think we're finally getting to a new natural language interface and kind of an AI as an interface where assistance becomes a new way of interacting. So instead of just having a computer with a lot of menus, you actually get AI assistance where you can just talk to the computer in natural language, just like you're talking to a human, and it'll talk back to you. And so imagine you can go into a CAD or 3D tool and you can both visualize it in a very realistic way, but you can also just talk to the CAD designer as a virtual designer in a way that's just like talking to a human, and experiment with things and have it adjust the model and adjust things kind of automatically without you doing a bunch of menus. And even people like me who don't know CAD, who aren't a CAD kind of expert, 3D tool expert, I can actually go in and start to just have a conversation with AI to make adjustments, to try things. And I think that we are going to move into this kind of new natural language AI as an interface. And that is probably the next really big leap past the 3D BIM model. And I think it's going to lead to great things, mostly for the professionals who use the tools. It's like, it is just a next generation tool. It's not going to do the work for you. It's not going to create the building for you. It's just going to help do some of the simpler things that maybe you had to do a lot of menus and buttons and hand work for. Now you can just say, oh, can you just move that over? And just moved over. Finally, I didn't have to go find what menu
and
deep down.
Coordinated at the same time.
Yeah. And I think it will just make it much more natural. And I was talking to my mom about this last night and kind of telling her this vision of imagine we're all going to be able to use these tools in the future, where today, if I said, hey, how many of you know how to use AutoCAD well? Like, you know, there are a couple people up here, probably not many people in the audience. Now imagine a couple of years from now, when it's AutoCAD Designer and it's just an AI you can talk to, everybody can use it. Well, it's just like having a remote graphic designer sitting next to you that you can talk to, and they'll do the work for you just like they would if they were a real person. Maybe not quite as good, but and they'll still need a lot of human guidance and imagination and creativity and kind of you guys checking over, making sure it is right, because it tends to hallucinate. We don't want hallucinations buildings like this, hallucinating AI. But you will be able to interface to it that way. And I think that's going to lead to a lot of new creativity and building.
Yeah, I would agree.
I think on that uplifting note, actually, pretty exciting stuff. Thank you again for everyone's time. I think we are at time. I got a signal. But we'll be here all kind of morning to answer any questions. And thank you so much for coming out today. And thank you again, Brendan.